Okay, moving on to 5.3, and we have graphs of rational functions in the form of ax plus b over cx plus d. All right, so this one's going to be a little bit, let's say longer, a little bit of a longer lesson. Okay, so when we're graphing these, and I'll show you with some examples. So we have the ax and the cx. So what it means is a number in front of the x and another number in front of this x, okay? So we don't have any x squareds or any x cubes or anything like that, okay? So just a number in front of each of the x and then a number at the end. Okay, so based on what we've already learned about vertical and horizontal asymptotes, which we did get in 5.2, and about positive negative intervals, which you did in chapter 4, and x-intercepts, we could then sketch graphs. Okay, we can sketch these graphs. Okay, so we're going to break it down into a few things. So in order to graph them, we need to know a few things, which is the vertical asymptote, the horizontal asymptote, the y-intercept, and the x-intercept. Okay, so whenever we ask the graph, we need to find these 4 things. Okay, so first one, vertical asymptote. We find that by seeing what number will make the denominator is equal to 0. Okay, so what can I plug into x that will make this whole 0? Well, we could plug in 1. So we have vertical asymptote at x equals 1. Okay, our horizontal asymptote, which we learned in yesterday's lesson, is we take if the exponents and the numerator and denominator are the same or less than on the top, then we could divide the leading coefficients. So the coefficient is 2 divided by 1, which is 2. So we have a horizontal asymptote at y equals 2. So let's go right over here. Our vertical asymptote is x equals 1. Our horizontal asymptote is at y equals 2. Okay, now we're going to find the y-intercept. And to find any y-intercept, or any y-intercept, the x is always 0. So what we do is we plug in 0 for our x values. So we have 2x minus 6 over x minus 1. So we're going to plug in 0 into the x's. So plug 0 into x. So we get 2 times 0 minus 6 over 0 minus 1, which gives us negative 6 divided by negative 1, which is positive 6. So our y-intercept is at 0 and 6. Okay, now we're going to find the x-intercept. And to do that, every x-intercept, our y value is 0. So we plug in 0 for y. So 0 equals 2x minus 6 over x minus 1. The y-intercept is always going to be what makes the numerator equal to 0, by the way. So whatever makes the numerator 0 will give your y-intercept. But just in case, I'm going to show you. So we cross multiply. So 0 times x minus 1 is 0. And this 2x minus 6 is left. Now we isolate for x. So add 6 on both sides. So 6 equals 2x. Divide by 2. And you get the answer of 3. Okay, so our x-intercept now is 3 and 0. Okay, now now the more tricky, not even that tricky, but we have to now make this chart here. So this chart is going to give us our positive and negative intervals. So it's going to tell us where it is positive above the x-axis, or where it's below the x-axis. Okay, so right now we have a few points, but now we kind of have to fill the rest of the graph out. Okay, so this is what's going to happen. You're going to take your vertical asymptotes and your x-intercepts. Okay, so our vertical asymptote is 1 and our x-intercept is 3. Okay, so now we're going to make a series of intervals here. So our vertical asymptote is 1 and our x-intercept is 3. So this is what we're going to do. So we're going to see what our values below is our lowest number, So in this case it's 1. So we're going to look for x values that are less than 1. Is it less than and equal to in the question? No, it just says equal to. So less than. So x is less than 1. Then the last one is going to be our highest number, which is 3. So x is greater than 3. And then we want to find values in between these two. So values in between 1 and 3. Okay, we use these values because they are affecting the x-axis. So we want to know when they will be above the x-axis or below. So it's going to be before or after these points. Okay, so if you were to plug in a value less than 1 into here, so by the way, what goes here in this first column are your numerator and denominator. Okay, so I put my numerator here, my denominator here. If there's multiple brackets, then you split them up in brackets. Okay, and then here is going to be our plus minus. Okay, so if I plug a value less than 1 into here, so a value less than 1 is 0. If I plug 0 into here, I get 2 times 0, which is 0, minus 6, which is negative 6. So if I plug a value into here, less than 0, I get a negative answer. I'm going to get a negative answer. So I'm going to put a negative here. If I plug in 0 into this one, I also get a negative answer. Because 0 minus 1 is minus 1. Okay? But if I have a negative on the top and negative on the bottom, the two negatives create a positive answer. Okay? Now we're going to pick a number between 1 and 3. Well, between 1 and 3, the easiest one to use is 2. So if I plug 2 into this x, I get 2 times 2, which is 4, minus 6 is negative 2. So I get a negative here. If I plug 2 in the denominator, I get 2 minus 1, which is 1, which is a positive answer. A negative and a positive makes a negative. Okay, now if I pick numbers larger than 3, so say 4, so 2 times 4 is 8, minus 6 is positive 2. And then if I plug in 4, 4 minus 1 is 3, which is also a positive answer. So 2 positive makes a positive. Okay, now we're going to combine all this to make a graph. So let's go with the easy things first. Okay, let's draw our vertical asymptote at 1. So vertical, meaning up and down, at 1. Then we have a horizontal asymptote at 2. We have a y-intercept at 0 and 6. And an x-intercept at 3 and 0. Okay, now we combine. So x values that are less than 1 is in the positive quadrant. So So it's above the x-axis, but it could only be in this part here because we have a point here. So we're going to draw curve as such. Okay, because we are doing rational graphs, so most of them are going to look like reciprocal functions. And then from between 1 and 3, so between here and here, we have, so between 1 and 3, it's going to be in the negative quadrant. So it's going to be negative. Okay, so between 1 and 3, it's negative, and then after 3, so greater than 3, it's above the x-axis. So it's here, because it's above the x-axis. And that's your graph. The glare is there. Okay, so vertical asymptote, horizontal asymptote, y-intercept, x-intercept. When it's less than 1, we have a positive answer. We're above the x-axis here. Okay, when it's between 1 and 3, we have a negative. So here below the x-axis, between 1 and 3, below. And then after 3, it's positive. Okay, next one. Or the last one. Okay, so let's do this again. Okay, so vertical asymptote, again, what makes the denominator 0? In this case, we have 2 plus x, so if we had 2 minus x, or sorry, minus 2 would make 0. So we have a vertical asymptote at x equals negative 2. If you want to put the add sign, you can. A horizontal asymptote, again, we divide the leading coefficients. So be careful here, there's a little trick one. The leading coefficient is 3 divided by this one, 1, because it's the number next to the x. So the coefficient has to be in front of the x's. So 3 divided by 1 is 3. So y equals 3. Okay, y-intercept. If you plug 0 into your x's, you get negative 5 over 2, which is negative 2.5. Okay, because this cancels off. So negative 5 over 2 is negative 2.5. And our x-intercepts, we plug 0 into y. Cross multiply, this crosses off. So we get 3x minus 5, add 5 on each side. And then divide by 3. So you get 1.7 or 1.6666 repeatedly. Okay, so now we have those values. So it's going to write over here. So go vertical asymptote is negative 2. A horizontal asymptote is 3. Y-intercept is negative 2.5. And x-intercept is positive 1.7. Okay, so to make these chart, again, you take your vertical asymptote and your x-intercept. Our vertical asymptote and our x-intercept. Okay, so our vertical asymptote is negative 2 and our x-intercept is 1.7. So we're going to go, what are the values below the lowest number? So which is negative 2, so x less than negative 2. Then higher than the highest number, so larger than 1.7, so x greater than 1.7. And then we want values in between those two. So x greater than negative 2 and less than 1.7. Okay, so if we plug in a number less than -2, so less than -2, so let's say -3, I'll get a negative value here and a negative value here, because that'll be -14, and this would be -1. Okay, but two negatives make a positive. Then if we pick a number between -2 and 1.7, so a number between that would be the best or easiest one is to do is 0. So if I plug in 0, I'll get a negative value, because it'll be 0 minus 5, which is -5. If I plug in 0 here, I get 2 plus 0, which is +2. A positive and a negative gives me a negative. And lastly, larger than 1.7, so if I plugged in 2, if I plug in 2 here, I'll get a positive answer, and then the numerator, another positive answer. And 2 positives is positive. So remember, this is the numerator, and that's the denominator. Okay, now let's graph all these. Vertical asymptote at -2. Horizontal asymptote at +3. Y-intercept at -2.5. And x-intercept at 1.7. Now we draw. So less than -2, these values at less than -2 have to be in the positive quadrant. So that would be up here, because all of them have to be positive, so it's going to make a curve. And then between 1.7 and -2 on your x's, we are below the x-axis. So that would be here, below the x-axis. Then after 1.7, you're above the x-axis. So here. All right, that concludes it. Homework is there. At the bottom, 272, look, not too many questions. 1, 2, 3, and 6A.